What? A project schedule is a timetable that shows the start and end date of all project tasks, how the tasks relate to each other, and usually which team members or other resources are responsible for delivery. When? It is a dynamic document that is created during initial the planning stage. Why? Project scheduling is just as important as cost budgeting as it determines the timeline, resources needed, and the reality of the delivery of the project. Project managers that have experience are better able to properly dictate the task, effort, and money required to complete a project. Who? Project schedulers develop and manage schedules for projects, mainly in the field of construction and engineering. They assist project managers with schedule planning, coordinate tasks, and monitor the timelines of scheduled assignments.
Meanwhile,
Good day. My name is Eliza May.
Nice to meet you. I'm Architect Paulo Esteban. Welcome to G-Rex Construction Company.
I'm glad to talk about my plans for constructing a coffee shop. In addition, I have a 4 by 60 meter property. So could you tell me which designs you can recommend to me?
Given my extensive background, I firmly believe that I can provide a design that meets all of your requirements. But first, can you tell me how much money you have set aside for this project?
This project has a budget of 150,000. I'd like to complete it in a month and a half. Is it possible for you to succeed?
It's no problem. First, I need to consult with my engineer partner about the timeline you desire and whether it works into your budget you have.
Okay, thank you.
Have a good day, ma'am. Engineer Taking, we had a project with a 4 by 60 meter property and a budget of 150,000. This is the shop layout I designed.
Okay, just give me 2 days to fix the schedule.
2 days later.
We are working on a project and you will be in charge of it. It's up to you to find the workers we'll need.
Okay, sir. For each activity, we require the services of an appropriate manpower for this.
Critical path method. I will be using this activity schedule for a project. The first thing is to first construct a project network. Second, perform forward and backward pass. Third, determine the project completion time. Fourth, calculate slack values. And last, state the critical path. And I will be using this node convention. A is the activity being described. T represent the expected activity duration or time. ES is the earliest start time the activity can start. EF is the earliest finish time. LS is the latest start time. LF is the latest finish time without extending the minimum completion time of the project. Let's first make a sketch to make it easier when drawing the full network. A. Activity A has no predecessor, so it will be begin at start. Activity B needs activity A to be completed before it can start. Activity C depends on B. Activity D and E depends on C. Activity F depends on E. Activity G depends on D. Activity H need both E and G. Activity I depend on C. Activity J need both F and I. Activity K and L depends on J. Activity M depends on H. Activity N need both K and L. Since activity M and N have no successor, they go to finish. So here is the network with the activity nodes displaying the letters and time. Let's perform the forward pass where the earliest start time and earliest finish time are calculated. A has no predecessor, so the earliest start time will be 0. Since it has 2 days to be completed, its earliest finish time will be 0 plus 2 equals 2. Now, B needs A to be completed before it can start. Since the earlier finish time for A is 2, then the earliest start time for B can start is 2. With an activity time of 4 weeks, B will have an earliest finish time of 4 plus 2 equals 6. C has only one predecessor, B, so it can start at 6 and earliest finish at 16. D has predecessor C, so it can start at 16 and finish at 22. E has predecessor C, so it can start at 16 and finish at 20. F has predecessor E, so it can start at 20 and finish at 25. G has predecessor D, so it can start at 22 and finish at 29. H has predecessor E and G. Since the earliest finish time of E and G are 20 and 29 respectively, and H needs both of them to finish in order to start, then the earliest time D can start is 29. The highest of the earliest finish times preceding an activity will be the activity's earliest start time. So H finishes at 9 plus 29 equals 38. I has predecessor C, so it can start at 16 and finish at 23. J has predecessors F and I. Since the higher earliest finish time is 25, J can start earliest at 25 and finish at 33. K has predecessor J, so it can start at 33 and finish at 37. L has predecessor J, so it can start at 33, finish at 38. M has predecessor H, so it can start at 38, finish at 40. N has predecessors K and L. Since the higher earliest finish time is 38, N can start earliest 38 and finish at 44. The project network's project completion time is 44 days. In total, the project network will be completed in 44 days. So now for the backward pass. Since the project completion time is 44 days, the latest finish time for the activities at the finish node has to be 44. That is, M and N cannot be completed in longer than 44 days. Next, we obtain the latest start time by subtracting the activity time from the latest finish time. Now N, the latest start time will be 44 subtracted by 6 is equals to 38. M, the latest start time will be the 44 subtracted by 2 is equals to 42. Now L has only one successor, N. So the latest finish time for L will be the latest start time for N. 38 and latest start time will be 38 subtracted by 5 is equal to 33 for L. K has also one successor, N. So the latest finish time for K will be the latest start time for N. 38 and latest start time will be 38 subtracted by 4 is equals to 34 for K. Now, J has two successors, K and L. Their latest start time are 34 and 33 respectively. The result, the latest time J has to finish has to be 33. Thus, the latest start time for J will be 38 subtracted by 8 is equals to 25. I also has one successor J. Therefore, latest finish will 25 for I and latest start will 18. H has successor M. The latest finish will 42 for H and latest start will 33. G has successor H. The latest finish time will 33 for G and latest start will 26. F has successor J. The latest finish will 25 for F and latest start will 20. E has two successors, F and H. The minimum of their latest start is 20. So the latest finish for E will be 20 and its latest start will be 16. D has successor G. The latest finish will 26 for D and latest start will 20. Now C has three successors, D, E, and I. Their latest start time are 20, 16, and 18 respectively. The result, the latest time C has to finish has to be 16. Thus, the latest start time for J will be 16 subtracted by 10 is 6. B has successor C. The latest finish will 6 for B and latest start will 2. A has successor B. The latest finish will 2 for A and latest start will 0. And now calculate the slack values. The slack values for an activity is defined as how long the activity can be delayed without extending the project for completion time. It will be calculated as latest start time subtracted by earliest start time or latest finish time subtracted by earliest finish time. Slack A will be 0 subtracted by 0 is equals to 0 or 2 subtracted by 2 is equals to 0. Slack B will be 0. Slack C will be 0. Slack D is 4. Slack E will be 0. Slack F will be 0. Slack G is 4 and same for slack H is 4. Slack I is 2. Slack J is 0. Slack K is 1. Slack L 0. Slack M 4 and the last is slack N which is 0. Note for example, activity D can begin anytime between 16 and 20 and it can finish anytime between 22 and 26. D can be delayed for up to 4 days and the project will still be completed in 44 days. Activities A, B, C, E, F, J, L, and N. These activities cannot be delayed at all without extending the project's completion time. Example, if C is delayed by 2 days, then the project completion time will be extended by 2 days as well, from 44 to 46 days. The activities without slack are called the critical activities and they form the critical path which is the longest path in the network. So the critical path here is A, B, C, E, F, J, L, and N.